I'm Andre. I run our CloudVision team here at Arista. It's always good to hear Ken's quality talk. I've heard it many times. It's really great. As Jeff said, my first network field day was just over 10 years ago. I was watching the video in preparation. I was a little embarrassed, but it's great to be here. My request: interrupt me, ask questions, keep it interactive. I'm going to be here talking about, if I go to the next slide here, multi-domain network operations and kind of the CloudVision platform and how we enable this. I'll be joined by Paul, who's going to show off the product and really make it real for you all. But I wanted to set the stage a little bit in the beginning, and especially for those of you who may be a little bit less familiar with CloudVision, talk about the platform, the architecture, our approach, and why I think the pieces that are really fundamentally different, in my view, to what other people are doing out there. So let's get into it. So what do I mean by kind of multi-domain network operations? If you look back over the past decade, certainly longer, right? Network operations for modern enterprises have gotten harder and harder, right? You've got this problem of your users, right, are in more and more places, right? In your campuses, in your branches, now work from home everywhere. You have your applications that continue to be more dynamic, whether it's running in VMs on your premise, in the public cloud, using SaaS services. Now you have containers, you have these ever more ephemeral applications running out there. And you still have this same kind of network operator trying to manage all of this, with everything from your advanced DevOps engineer who's trying to build these fully autonomous pipelines, pushing things across the network, to your level 1 help desk who is picking up the phone, answering that ticket, helping you when you call it and have an issue. And as Jeff was talking about, over this time, a lot of what we've been espousing is really trying to simplify the network design, right? Bringing cloud-based networking principles across all of these environments, because historically these have all been different silos. And if you look at the tools that have been provided in these environments, even within one vendor, they've often been tools for each of these different environments. I've got my data center tool, my campus tool, my Wi-Fi tool. Sometimes you have different tools for different operators within the same environment. And this just makes everything much harder, especially when your goal is to provide this consistent set of operations and get the advantages of cloud-based automation. And so, when we started CloudVision 7-8 years ago, we were very focused on data center, right? It would have been very easy for us to fall into this same trap and really focus on that space. And actually, the reason we didn't is not because we had this vision of multi-domain network automation. It really was because we started by focusing on the platform, right? Ken talked about this a little bit. How do you build the right platform for network management and analytics that is going to be applicable across any use case you go after? And I'm going to apologize for very much the non-marketing slide. This was the original pitch from engineering. We were going after trying to solve a different problem, right? Back 7-8 years ago, if you think about why most people end up with these kind of limited tools that are domain specific, you start with, what's the customer problem I'm going to solve? What data do I need to get that? How do I get that data? Great, I'm an SNMP pool. It's the only thing that's available. We were talking with the largest cloud titans at the time, trying to help them move away from SNMP because they have this problem at massive scales, right? They did not have the visibility they needed, what with pull-based access to telemetry and this very limited subset of data to actually be able to monitor their data at scale. And so instead of starting with, we're going to build a network management platform, it was, reverse it. How do we build a platform to get all the data, all the state from all the switches and all the data centers at the time, all the places in the network, shove it into a big multi-tenant distributed cloud-based system, store it there for all time, provide great API access, we can build whatever application we want on top of that. But that is the kind of fundamental problem and something that still most customers don't have access to, or most other vendors don't have access to. We had the big advantage of starting with EOS. We had a single network operating system to support. It's already built around a database, right? So our ability to get all the state in the system, we stream it all out of that database, we get it into our CloudVision backend, and we're off and running, we have access. And so, kind of taking this into a little bit, again, more of a customer-facing slide, we have access to the full data plane, the full control plane, the full, all your BGP routing tables, your full route table, multicast, your management plane, right? All your interface counters. We even have data plane traffic. We have visibility into your flow tables, who's talking to whom, using features like IPFix or INT that's available in these platforms. And there's kind of a lot of nerdy technical details on how we build this platform to scale to this, which I could talk about. But if you take this back to the customer perspective, what this means is you have all the visibility, all the data you need to actually know what's wrong, right? Be told when something's wrong, know what's wrong, see where the problem is, and resolve it without having to go to the CLI or jump around, right? And that's ultimately what this platform provides. And then we're able to build specific features on top of that for data center use cases, campus use cases, multi-cloud use cases, right? And so that's really where we started. Oftentimes I'm asked, like, what do you really mean by everything? I use the term state a lot. Like, it's everything from the most generic interface counters, right? Is my interface up or down? To weird platform-specific chip counters, which are the things that actually tell you when there's an issue in the chip, right? The things that actually, when you call up TAC and there's an issue and they're like, oh, run this command here, that's the thing that's telling you there's an issue, right? Because those are the interesting, hard to debug problems are not, I've got errors on this link, right? It's when something's not going right and you don't even know where to look. And so we're able to get all of this. If you can see it at the CLI, we have it. And that's not because we're pulling CLI commands. It's because it's all built on top of a database that holds all this information. And so we're able to stream all this data into the CloudVision backend. And as we've evolved here over that 7-8 year period, as our use cases have expanded, right? Still single EOS, still the same CloudVision, we've evolved the infrastructure to continue to take in more data from more sources. We now call this our NetDL architecture, right? This is a data lake in our cloud service where we have devices across our customer base that across different use cases, they're all streaming into this one centralized CloudVision, right, across multiple tenants. And we now have access in that data lake to this anonymized data to be able to actually do interesting AI and ML models, right? Everyone likes to talk about the AI ML part at the end, like, here's what we detected. They miss the foundational part, which I believe is still a fundamental problem in most network management platforms today is, do you have good data to actually go off of, right? And so, we've really focused on building how do we get all the data, and we can solve all the problems after that because we actually have access to what we need as opposed to needing to solve for a given use case, how do I get the right data to make a decision? So we're going to go through a few use cases on how different operators interact with the product and for different use cases and what they see. On that example of kind of building models here, one example I'll point out that I love, we spent a bunch of time looking over about a year's worth of data across a bunch of customers and working very closely with 2 different customers to try to solve this problem of how do you detect optics that will fail before they fail. And we're now kind of jumping to the end. We're now at a point where we can kind of detect optics failure about 6 weeks before they will, right? And so that's enough time to actually plan before you start seeing errors, right? How do you do this? Well, you need 2 things. You actually need the data. The data here is really looking at, there's very fine-grained data that comes out of each of these modern transceivers these days. It's called DOM data, digital optical monitoring. And so you monitor the signals over time. And unfortunately, it's not as simple like, well, when this goes down, your thing's going to fail, right? Like every link up is different. Every cable length changes what these properties look like. You have to build a model that then looks at each individual transceiver over time to detect when it's going to degrade. And what you see in the picture over here is one we were monitoring and we graphed separately of here's where we detected it failed. It then goes down the cliff. It fails. We then RMA it. And here we are in a different place and you're off. And so this is this sort of thing we can do by having access to this multi-tenant data, this rich set of data in our cloud service and being able to apply and like look at that data to be able to solve the problems that are actually impacting our customers. And so I'm going to set the stage in a second on kind of the network operations side. But one last piece here, I mentioned the cloud service. CloudVision is available as an on-prem deployment and as a cloud service. One important thing I want to point out here is, I think that a common pattern is you have a product that you then go and try to make a cloud service. You have this VM, and you have this OVA, you put it in the cloud as a cloud service now because you manage it. That works. You don't really get the advantages of cloud scale that way. You really have to think about how you build your application and your product upfront to be a cloud service and truly take advantage of that elasticity. And so we actually started in the opposite. Naively on the engineering side, we thought we were only going to have a cloud service, and we built this out as a fully containerized. Each component is individually scalable Kubernetes-based architecture runs in the cloud. We have an SRE team that manages this. And then, very quickly we realized for our data center use case, we really needed this on-prem. And so we took all of that and we constrained it into a 3-node cluster running Kubernetes. But this is how we actually have a cloud service and an on-prem product that get the advantage of the cloud, but is the same code, right? The same containers running in all of these. They're tested in both environments, but we're not building two products, and we don't have the challenge of adding a feature and then not having it in one or the other. Yeah.
So what's the largest number of devices that are in CVP running in the cloud?
So the way to frame your question, so CloudVision is in the cloud is deployed globally. So we have different regional locations because different customers have different requirements for data locality, things like that. Each tenant, so a given cluster can have many tenants that are across this. Each tenant today we limit to 1,000 devices, which is an application level constraint that we're continuing to be at 2,000 in a couple months. We're testing that right now. And then in a given cloud service, you can have thousands, tens of thousands of devices. Right?
Okay, so I would say in that context, for a given customer/tenant, you're saying it's 1,000.
Yeah, and that's largely that's a constraint we've placed on testing, right? So there's, as Ken said, CloudVision, just like EOS, we support what we test, and we test in an automated way. And so as we continue to grow our use cases, we need to continue to grow our supported scale. You've got kind of the data center use case, which is often a smaller number of larger stateful devices, and the campus use cases, which obviously drive much larger number of smaller devices. And so this is all about how do we test this, across those use cases. So.
And as a follow-up, do you have to deploy an on-prem type of proxy piece of software to get the data from the on-prem system into the cloud?
Yeah, that's a good question. So there's kind of two related data security questions that come out of that. So no, we don't have a proxy. You can use your own internal HTTP proxy. So each device is running a state streaming process that is talking over gRPC, so HTTP2 with SSL, and it can go through a proxy. So if you want to push everything through an HTTP proxy, great, that works. But there's no kind of additional infrastructure required there. You can just run your devices. The other question that often comes into this is, I don't want to send this over the internet. I want to use my direct connect or something like that. And that's fully within your control based on your routing rules within your campus or data center.
Okay. Yeah. Thank you.
Yep.
Oh, one last question. So Ken mentioned the bug reporting aspect of CVP. So when I go into CVP, I'll see a report that says you've got 1,000 devices in here. Some of them are running this version of code, and this bug exists on that version of code.
Yep.
And a while ago, the CVP wouldn't differentiate whether or not that bug actually applied to you. Like if it was a BGP bug and you were not running BGP, for example. Has that been?
So, I mean, that you may have hit a specific bug there of all things, but no, the goal has always been that the bugs are tagged with what they apply to, and we leverage tags from the device to do that. So the goal is very much to not just say, here are all these bugs, maybe they apply to you, but really say, look, these are the bugs that are severe enough, and importantly, that are curated by our attack. They're hitting people in the field that you should know about. We think this is important enough that you should know about, and this should warrant you upgrading. It's hard to be 100% accurate. Like or maybe I should say it differently. There are bugs that are unlikely to happen, but may happen, and we still alert you on that because they will happen at a certain point.
No, I mean the case in point was we were being reported on, all of these devices running this version of code, and you should upgrade because of the CV. But we weren't running the feature.
So that shouldn't happen. That's part of the feature is tagging it and applying it.
Oh, okay.
So it may have been an issue with that one. Yeah.
I see.
But it's a very cool feature. I mean, I think this is true on the analytics example as well. Like getting your TAC involved in this process of how do we help provide a better customer experience proactively and not just when they have to pick up the call is an important part of this, and they've been great in this way. So before handing it over to Paul, I'm going to talk a little bit about kind of the network automation, network operations side of this. And a lot of what you're going to see from Paul is on something we call studios. So what is a studio? So studios are kind of this foundational aspect of our network provisioning system. At its core, it's a network-wide data model, right? So if you think about deploying a data center, deploying a rack, deploying a new service, like there are certain attributes of that you're thinking about that you need to apply for that location. And then there's a lot of detail of what actually gets deployed on the device, right? And so that network-wide data model captures the attributes of the location you're trying to deploy. And that is what users drive either through a UI, so like the nice point and click UI for the non-expert user, as well as through an API for machine-to-machine interaction, whether it's from an Ansible or something like that. And this then gets translated into per device configuration, which is ultimately what's pushed out. Studios are hard to describe at some level because I think they're really fundamental to what we do, but it's easy to confuse them with kind of, well, this is the same as what everyone does. So let me try to make this kind of comparison. If you look at the challenge of multi-domain network management and the scope of operators that you're trying to go after, like most tools make one of two choices, right? So they build the admin tool, which is largely what we had originally in our data center use case, like for the network architect, and is what studios are built on top of, where you're really trying to provide maximum flexibility to the architect who really knows what they want to build. And the other is that you build very rigid wizards, right? It's like, let me be super prescriptive on the network you're going to build, and we're going to do it really well. But if you want to do it differently or you have a different workflow, well, we'll go build another wizard. And so what we did with studios to try to address this broad set of users that we're going after is to try to do both, right? So we have built-in studios. I think Jeff mentioned this on Arista validated designs, right? You want to build a layer 3 leaf-spine network for your data center? Great. Here's what you build. You want to take our recommendation? Do it. So out of the box, you load CloudVision, you go run and deploy it. You're good. You want to go build your own custom workflow, right? Your workflow, how you want to deploy services is different. You want to change an existing studio, you can build your own studio and you still get the same experience from a UI-based plus API-based integration that you would had we built it in directly. So we're trying to enable both types of users to be able to get maximum value out of the product without either having a rigid wizard that we then have to go change or having it not be simple enough for that simplistic user. And then, of course, at the end, it's not just about defining configuration. It's the whole NetOps experience. This is what we'll show off here. Everything from how do I define the config before it shows up, zero-touch onboarding, ongoing changes as you expand your network or as you need to make changes, and all around leveraging our streaming telemetry to be able to know, did I break my network, right? And both driving that into the change control process, but also what other changes do I need to make?
Can I jump in with a question here?
Yeah.
You're talking about all this, like collecting a whole bunch of data and telemetry to just figure out the state of your network. There's a whole industry and suite of products built to do network monitoring. Does using CloudVision and of what you built in here kind of negate the need?
I think it's kind of ridiculous if you look at it, right? Like, you have different tools that are doing flow tracking and config management and monitoring and, right? And then you do that across different operations. We're trying to provide a tool that provides all of that. Like so our flow tracking, for example, is not going to replace kind of regulatory based, I want to do high level flow collection and store everything for a year. But it's going to be really good at making it so that in your debug process, you have access to flow data and you can leverage that when actually trying to figure out what's going wrong, right? So I think that there's a lot of value in having all of this in one tool that, again, that kind of separate tool, separate domain approach doesn't allow you to tap into. Instead, you're kind of jumping around.
So if I understand that correctly, this takes you so far, but you would still need those other monitoring solutions and products to take you the rest of the way?
There are use cases where those tools may be required, but I think from a general data center, like if you wanted to deploy an Arista data center network and manage it, monitor it, like this does everything. You don't need another tool. That's right.
Gotcha.
And you wouldn't want it because then you have all this data that you're putting in a different tool that you have to manage, that you have to figure, like from an engineering perspective, the fact that we're investing in one infrastructure and making it really great has lots of benefits too.
Yeah, I'm just kind of comparing it to the silos that are in some IT departments, the management group that has, a few resources on it, and the network team that looks at other things.
This is what's hard, like the siloing of the tools we provide as vendors drives siloing of operations, right? So like you have experts at different tools who then have to like coordinate, but now they're different teams, right? It drives these very weird things when what you really want is, look, we're trying to solve this broader enterprise networking problem. Yes, we all have domains of expertise, but we can do this in a common platform.
Okay, and then just one more to add on top of that. So this is network state and the health of your network.
Yeah.
Can you take that one step further and look at, applications, help out with that?
We do this in some cases very much driven by how do we enable the network operator, right? We're not trying to replace your APM, right? Or and our user is very much the network operator. But I think part of what's challenging in today's environment is the network operator is blamed for everything, and they have no idea where anything's running, right? It's like, hey, my application is not working, my user is having an issue. Well, where are you, right? And I think that's where we can really help. If that makes sense. I really need to turn this over to Paul. My final statement is obviously we need to fit into the broader infrastructure automation picture. We have really strong APIs and integrations into Ansible if you're trying to drive across a multi-vendor environment and drive through CloudVision Studios, ServiceNow for change control, approval, Splunk for sending alerts out. So obviously this is a part of a broader ecosystem and problem that people are trying to solve. So with that,
from a full stack kind of a standpoint, I mean, you've got some of the tools as far as like ServiceNow or something. Do you have anything where you're going to integrate with like the APM world where you can, hey, this application has a problem. You can take that data and correlate it to an event on a network? Or is it kind of, we've got these two separate tools and you need somebody to take data from A and put it into B?
Yeah, I mean, I think not being the APM, but leveraging that and enabling the network team to quickly say there is a network issue that's affecting this application versus not is certainly a direction we're going in. Yeah.
Okay.
So I'm Paul Drews. I'm a technical marketing engineer for Arista. And today we're going to see how this is applied in action, right? So how this is applied across these different domains that we've got here. As Andre mentioned, there may be many tools to accomplish a similar thing within my environment. And as we have one platform with CloudVision, we're going to see how that is adopted by these different operator types and how it's applied across these different domains. So in my example here, we've got a typical large enterprise where they've got a number of DC networks, they've got some campus networks, and then they've got their NetOps team that's comprised of some DC engineers, some campus admin personnel, and then some field techs that are out on the field. And we're going to essentially follow a day in the life of this organization to give you a real good idea of how this multi-domain approach can be consumed by the user. So firstly, our DC engineer, we're going to define and provision a new Evpn service across our data center. We're also taking Ken's word that we need to upgrade. We need to be up to date. So we're going to schedule a network-wide upgrade that we've got planned for tonight. Secondly, we've got a campus engineer that's going to deploy a new wiring closet into their campus network. And as part of that workflow, automate the update of an external configuration management database, which in this organization, may be some requirement around a broader set of tech asset tracking. And then lastly, our field tech, they're out in the field, they're looking at this new campus that's been deployed. They're assessing whether some wireless APs are connected to the cloud service. And so we're going to see how we can help them troubleshoot the issues there. Now, in this demo, we'll be talking about CloudVision Studios to define the configuration changes. We'll look at change control and how you automate those changes, the rollout of those changes. And we'll weave in some real-time telemetry there so you get an idea of the types of things that can help the operator. Okay, so it's a busy day ahead, so let's get started here. So we're going to log into CloudVision firstly as the DC engineer. And like Andre was talking about, this network streaming state models, this is an example of a dashboard we've put together
where you can see that we've got a topology view here of the multi-domain network. We've got some device state that's streamed in, so the MLAG information, BGP information, that type of thing. Some compliance donut graphs there, PoE information, that type of thing. So we can filter this down. So we just want to look in at the data center networks. Here we've got a leaf spine network deployed, a couple of spine switches, some leaves deployed, and some existing VNI that is deployed across the network. So we're going to create a new workspace to deploy this new Evpn service. And the workspace is essentially a staging ground for us to propose these changes. So we have a list of our studios here that are available built in or customized by the user. And we're going to use the Evpn services studio to look at the current state of what's deployed on the network, but then add to that with our new Evpn. So in this case, we're applying this to all the leaf switches in the DC. So that kind of captures the scope of this particular studio. We've got a tenant defined, a couple of VRFs already deployed, and a couple of VLANs as well. Now, VLAN 101 here, you'll see a use of tag. So again, we're using a tag called role leaf, which means that all those leaf switches will consume this service or this VLAN. And in the second one, we're using a different type of tag here. So a service tag for just our corporate applications. So essentially creating our logical view of a business requirement and then tagging devices with those with that particular tag. In the example of a new one that we'll configure here, we've got a service tag that this time we'll call trading apps. And you can see this live tag query update. So it's matching only on the first 4 leaf switches in the DC. So we've assigned those ahead of time so that we're ready to deploy this particular service across those leaf switches. We give the parameters that we're looking for within the Evpn. We can click an action here to pull in an IP address from an external IP address management system. And essentially we're now, we've got the VLAN provisioned or defined and ready to be deployed across the network. Because this is an Evpn setup, you can also define the VLAN aware bundles. So defining those MAC VRFs that are comprised per collection of VLANs here. So now we build the workspace. So the workspace is where we propose those changes, and the building of that workspace allows us to evaluate what studios were modified, what tags were modified, and essentially move through a build process that looks at the inputs from the user as they were input to the studio, validate them, create a configlet per device as it relates to those studios, and then validate them against the devices themselves. So you can see here a diff view, a little bit hard to see, but the green on the left shows new lines of code that are going to be that are proposed to install onto the network versus the existing running config. And so we've got our VLAN configuration here, our VXLAN and BGP configs. So when we submit the workspace, this now saves those changes back into the studios or our mainline version of code of the network, ready for future modifications to this. Now this moves then into our change control process. In this case, we're just going to review the changes and we're going to approve them. We'll look at something a little bit more complex shortly. So when we go ahead and execute the change, this particular change will execute these in parallel. But you'll notice down the bottom right, we've got some metrics that are streaming in from the network. And we can monitor these as the change gets rolled out. So if we look at the switching state that's coming in here, we can monitor as that VLAN gets deployed and the point in time that there's from 9 VLANs configured now and then 10 VLANs configured. Right, so we can monitor things as the change gets deployed, which otherwise might have to jump to multiple tools to view. Jumping into the device view, just let's have a look at the VXLAN table. We can see the new VLAN 102 that's been deployed. But because we've got this state over time, we can also compare against a previous point in time. So back 30 minutes, we can compare, we didn't have these VLANs deployed 30 minutes ago. We can also compare between devices. So between leaf switches in our DC at that particular point in time, so leaf 1A got 102, but 3A did not because it wasn't tagged with that particular service tag of trading apps. And these are different logical views that you can look at the current versus the previous state, for example, a MAC address table here.
Can you roll back that change? Like say you deployed it and you're like, oh, you know what? Didn't like that. Is there just like an undo button?
Yeah, so when you complete a change control, you then, when it's successfully completed, you'll get a rollback button, which then creates a new change control to run through the same process.
Do I have to do anything other than just hit roll back and deploy? Do I have to like unwind my changes?
No, when you create the rollback, so when you click rollback, it creates a new change control. So it follows the same process because I'm going to modify my network. So it still rolls through a new change control. But essentially it's going to reverse the changes. So I don't have to look at what I'm going to reverse. It will know what to reverse based on that change control.
Sure.
Okay, so our DC engineers are now moving on to scheduling their deployment for the network-wide upgrade that they're planning. And as part of this, we're going to see that change control process and how we can orchestrate the change using templates. So in this view here, we can apply an image bundle. So that single EOS that we talk about being applicable to multiple platforms across the multi-domain network. In this case, we're applying a new EOS image bundle to all the DC devices. And we'll go back into that familiar change control view. This time, when we create the change control, this is for an image upgrade as opposed to a config change. And we're told that, okay, well, this is going to require a reboot. This is a full EOS upgrade. And we don't want that just to go ahead and do that. So we can stage this in a particular way. So using a template, we can essentially orchestrate the way that this automation flow is going to work. So you can see we've split the stages into, we've got our spine upgrades, we're going to enter maintenance mode, gracefully drain traffic away, upgrade the image, exit maintenance mode, traffic comes back, run an action, in this case, monitor the BGP steps and compare them before and after the change. We'll proceed to the next spine, and then
When you're going through this and you're building out this flow, is this something that you're doing, like I would have to go in and build, or is this something that, hey, you're doing a spine and leave? Is that flow kind of a template pre-built?
Yeah, that's a good question, because if you don't use a template, you have to build this, right? And you can build it the way that you want an upgrade change control to proceed, right? So the idea here is using templates, and I'll show you the template and how it's built. But essentially, that's a way to quickly implement the way that you want to orchestrate the change based on some parameters that you define.
So kind of a follow-up to that.
Yep.
If I'm applying a config change, for example, and I want to create a kind of a flow that says, okay, now that this config has been applied, I want to run a bunch of show commands or look at the state of the network to see if the change that I made achieved the operational state that I was going after.
Yeah.
Is that possible to do through the system?
Yeah, certainly. So you'll note on this particular change in the MLAG section here, I've got snapshot network health. Now, a snapshot is essentially an action that runs that will run a bunch of show commands against the devices, right? So let's say as part of my change, as I manage my change now, I'm probably running a bunch of show commands, storing them in a text file, and then keeping that for before the change, and then doing the same after, and maybe doing some kind of diff, right? To validate that my change hasn't had a negative impact or similar. So this essentially will automate the process of grabbing that text data so that I can then store that, my change control system. Maybe I've got to keep a record of that or something, so I could export that.
So it's capturing the output, but it's not actually doing a validation. Like, for example, if I'm wiring up, 2 new switches, and I know that, this interface should be connected to this interface because I told my system that that's how that should be wired, but the tech guy accidentally didn't patch panel it right.
Yeah.
The only way I would be able to see that from what you just said was that I have to kind of eyeball the text output.
So, I think we built the change control system to allow you to basically take your runbook, which is often just like manual, now check this, store this there, and be able to automate this, right? So in your environment, if you want to check the following things, right, like you can write a script that'll do it and make that a required part of the upgrade. To your question, there's kind of stuff we build in and build for you, and then there's stuff that you build yourself, and we want to have that nice flexibility of having it work well out of the box, but also give you the flexibility to add your rules. So like your check on go talk to my external link database of what topology should be there, make sure it's actually wired that way. If not, stop. you can totally implement and change the block. But we don't have first class support for it, so it's you script it yourself, but it allows you to put that in there.
So you can actually have separate scripts that are in there. So
Yeah.
at any point, I've got a Python or whatever it might be,
Right.
do this thing when it comes back. Yes, this, your script, I would presume, is going to return either a pass or fail.
That's right.
Okay.
It's got access to the CloudVision database when it recovers as the user executing it, so you can get access to state and check things. So again, we have various built-in things. So like checking MLAG upgrades are like seemingly easy if you really want to wait for your links to come up, for example. Afterwards, it's supposed to go to the next one. And so we have checks like that are built in and just like, look, everyone's going to want this. It's the same thing. Here's how you wait for your interfaces that were up before to be up again. Things like that.
Yeah, and that monitor BGP that I mentioned as well is one example of it's included, therefore you can, it's included, but it's not a built-in as such. So you can look at the script and you can modify it, create your own version of that. And that's looking at the actual state in CloudVision before and after the change in terms of my BGP peers, etc. So if I've done an upgrade, has it all returned to the state that I expect? Okay. All right, so our MLAG upgrades, like Andre mentioned, you want to do an MLAG health check, so you can do the A side before proceeding with the B side, so you can maintain that network connectivity. And in this case, I'm going to, rather than execute immediately, I'm going to configure this so that it executes at a particular point in time, or schedule this for a particular point in time. So in this case, we'll set it for 11 p.m. tonight. And we still need to approve this, right? So it needs to be approved before it would then be executed at that time. So it's, again, a similar workflow, reviewing what's being proposed. In this case, the image is being upgraded. So we can validate that. Also, when we're actually planning to schedule it and essentially approve it, and it sits there in an approved state. So when that time rolls around, it will execute, create the necessary logs or events associated with that.
So with that approval process, is that something where you could have an integration with like ServiceNow or something as your system? You put it in here and you request the approval, but it goes to another platform. Once it's approved there, then it comes back and updates here?
Yeah, you could implement that workflow, and we've had examples of doing exactly that, yeah. All right, so let's have a look at the template just to give you an idea of the how these are built. So the template itself is built into these stages. So you've got an action bundle, which is the action we were talking about, or a collection of actions. You can filter the devices, so we're filtering based on a regex. And then you can order them in series versus parallel. So for example, you want to do the spines one at a time, but you might want to do all the A leaf switches at once and then do all the B switches. The action bundles are a collection of these actions, exactly that. So in here, we've got the maintenance mode actions and the monitor BGP stats, which we've defined to request certain parameters that we're putting in, the user is putting in.
So I've got a question on the device filter. Can you filter by tags rather than just a regular expression? There was a drop down there, so I wasn't.
Yeah.
What kind of your options?
Most of our UI is very tag based, so we really focus. Where tags is everything from what's the role, what's the location, what's the type. So I'd be surprised if we didn't, but I don't actually know for that specific. That's a much. I mean, people do like the hostname regex, but I think the tag based is certainly what we like there too.
Yeah, tags are very extensively used in CloudVision. We saw them in dashboards. There's other, like we can do it and use them in events. And so, we like to use more and more that tag query language, because it's also got logical operators that you could say this tag and this tag, any devices that match that, or this tag or this tag or this tag, based on what you want to see. All right, so let's move on to the campus. So the campus engineer here is going to deploy the new wiring closet into the existing network, and they're going to do an integration with this external CMDB. In this case, we're using Autobot as just a means of providing some kind of inventory management for our campus network. So we'll log in as a campus engineer here. And we're presented with the same multi-domain dashboard. Again, the dashboard was fully customized based on what we wanted to see here. And we can filter that down to the campus devices only. So we've already got one floor within this campus network defined, and we're going to deploy a new one. So now you can, there's grayed out studios here that this user is using our role-based access control for studios. So essentially the campus user, we don't want them to be able to access data center fabric, studios, etc. An organization can define the studios that they want to use, but then control the access based on the user. So again, we'll create a workspace to deploy this new wiring closet. And we'll use some tags. So this is the tag interface here where our 3 new switches, 2A, 2B, 2C, we're going to tag them with that network domain campus, which is then we'll capture those devices elsewhere within CloudVision as we query that tag. Then we're going to use our Campus Fabric Studio. So Campus Fabric Studio is a simple set of Arista best practices design methods to deploy a campus that we've predefined. We've added those devices into that new campus. We've got our existing VLANs configured here, our campus spline devices, and we'll add a new campus pod. So we're calling a wiring closet essentially a campus pod or collection of switches. And so when we add the devices into this particular construct of a campus pod, we can also assign them per device roles. So I'll talk more about roles, but then we can also assign, say, an in-band management IP, grabbing this from an IPAM, external IPAM. Now, MRAG roles. So we've got some devices here that are MLAG role primary and then secondary. And think of those as an MLAG pair at the top of the rack in the wiring closet. And then I want to add other devices to be able to scale out that logical unit. So I add them as member devices. So essentially they're redundantly connected to my 2 MLAG switches. And I can scale that out for however many physical ports I have in that MLAG pair. Let's add a VLAN. So we're also deploying some new Arista APs as part of this network. So we'll define a new VLAN for the wireless APs. We'll grab the virtual IP that's been defined in the IPAM. And that's all we need to do to provision that new wiring closet. But let's now configure some interfaces.
So when you say that you're getting those IPs from an IPAM, is that within this or is that connecting to an external solution?
That's connecting to an external. So again, it's using an action, but a different type of action where it's auto-filling the field that we've assigned that action to be paired up with. So in interface configuration, we've got a concept of profiles that we've defined here. And just think of a profile as I've got a certain type of device or user in my network, and I've got some common config that I want to deploy onto those types of interfaces. So we'll just give it a common description. We've actually put a variable in here, $1, which allows us to further append further description based on the port. And now we'll use tags again. So in this device group query here, we could say campus pod 2, and we can see the live match on the 3 new devices that we've added. So now this effectively gives us that view of that entire campus pod, all the devices, all the interfaces, as one logical unit that we can then go and configure for a particular type of user or service that exists in our campus network.
I have a quick question about the information you're putting in here, and maybe I missed it as I was busy twittering. Like VLANs and cable maps and things like that, do they all have to be entered in here manually? Do you have external connectors to pull them from other systems?
Yeah, that's a good question. So there's a few things you could do. There's certainly text fields, as we've seen, or as you're seeing now. We've seen the action of linking to an external system from, for example, an IPAM. And then the other option is that we present everything via an API, the CloudVision API as well. So it's completely feasible to script this entire thing that I've done in the UI, but instead through a script.
Okay. Thank you.
So is there anything as far as right now you're going through and kind of configure this is like an AP port? Is there anything, LLDP or something where AP is plugged in and it just, hey, this is an AP, I will configure it as an AP port? Is there something where—
That would be entirely possible to script that. You'd have to decide of whether you then want to just learn that and then immediately execute a script without some level of control. Like we've obviously got a lot of control built into the change control process. You might have something similar in the CloudVision Wi-Fi component where you need to accept that, but it's entirely possible to script things here. So when we enter the description here, this is what will then get appended to that common, in this case, wireless AP's description. So if we had particular users that we were defining these ports for, in this case, we've got a couple of APs and we're just listing where that location is. It just helps in terms of automating the config that needs to get deployed. All right, so we're done with our campus. So again, let's review our workspace. And we can, again, look at where the studios that we've modified, the tags that we've changed as part of the workspace. And we've validated the changes, validated the inputs, compiled the new changes, and again, get to review this versus the existing config.
Will you be going into details about how the port profiles are defined and the capabilities of the port profile?
Not more than what I've said, but if there's a particular question. So the concept of a profile is entirely defined within that studio. So really it's a case of defining a set of inputs that I want to use elsewhere within that studio to help optimize the result. So in that case, a interface profile is defined, let the user create a number of common deployment or configuration types, and then apply it on a per interface basis.
I mean, I think this is where the kind of customization ends up being really important because, you know, it's a fairly simple port profile and you say, you know what, I really want to configure X on my switch. It's like, great, go add that as a field. You can pull that into, and now your port profile can go and generate that as well, right? So it's not, we have our own best practices and kind of pieces, but it's fully customizable to be able to, you know, deal with a different sort of environment that maybe we didn't envision or different requirements.
But in that port profile, is that where I put my config, basically?
It will generate the config.
So it's responsible for generating the config.
Yeah, that's right. So in the studio itself, you define the schema, which is what the UI looks like. Mm-hmm. And there's variables there that are defined. And then there's a template part of the studio that then executes code, looks at the variables that were input, and maybe there's some predefined config that we just want to include. And so the template is where that's defined.
Okay.
Right, so the workspace is building. Again, this is saving those changes back into our mainline code or our studio code base, and we'll roll into the change control here. So this time we'll use a different template action or a different template that we've defined for the campus. And in this case, we're just splitting each device into just a few sections. So run the task and then run this action that's going to populate this external CMDB. Here's our Notabot instance here it's only got the initial 4 devices connected in. And so we'll move through the review and approval of this. In this case, we'll just execute immediately rather than running through an approval process. And it will proceed with the change, right? So notice how the ordering of this one may be a little bit difficult to make out, but they're running in parallel, and there's a little equal symbol to that signifies that. So this is then reaching out to the devices, making those changes to the devices before then proceeding on to the action. So we've ordered that in series within the stage. And this is just one example of integrated with Notabot, but in reality, this is just a script that interfaces with a system with an API. So this could be ServiceNow or something similar, or some other IP address management system. And there's our 3 devices. It's essentially populated them based on the APIs available in Notabot. So essentially, we've helped automate a series of operational processes that the NetOps team may have to undertake manually otherwise. So here's the resulting. Yep.
So I got a question. So for your customers that are all Arista, like it's complete Arista homogeneous network, I can see how this would be amazing. But what are you have customers that have heterogeneous networks where, this is going to be a part of a change to a broader, set of changes. And in those situations, how do they approach that problem? I mean, I get, this will be the answer for Arista, but how do they handle like, okay, now I got to, make some changes to a load balancer or, another set of switches by another vendor or access point or whatever it is as a continuous workflow? Is it just, well, that's on you, build your own pipeline, do your own thing, automate the Arista part with the CVP APIs, and is that kind of the strategy?
Yeah, I think that the place where we see people being most successful here is they're thinking about what's that layer above. Like every vendor provides their own solution. Multi-vendor management from a vendor is hard.
Right.
And ultimately, I think there's also this question, which is it's not just about the network. There's the broader infrastructure. And so I think that the people who are most successful at this, and certainly what we recommend if you're looking at that problem and you're an organization who can take this on, is we'll leverage something like an Ansible we have built in here where you're driving your broader network change through CloudVision. or through some other third party. And you're able to orchestrate that across a heterogeneous network if that's what you have there. And it doesn't have to be Ansible. There are people who do this with Jenkins and Git or with other tools, but that's where we see people being most successful in terms of solving the broader infrastructure problem across not just Arista. A question we'll often get is like, why use CloudVision? And like, actually, most people who do that also use CloudVision, and that's both because we're really taking care of the Arista part of it. There's also all the monitoring that goes into all the checks that they can go in there that like an Ansible doesn't provide out of the box. And so there's all that value that's still there for you, even if the starting point of your automation is outside of CloudVision. Yeah. So that's often what we see.
Yeah, no, I was just curious because I can see that this platform theoretically could drive other systems.
Yes.
Like, like you just said, I'm talking an Autobot, it's just an API. Mm-hmm. So if I had a wireless controller that was, portal-based SaaS system, theoretically, I could drive that activity through a workflow by CVP. And I was just curious if anybody's attempted that kind of approach and to what degree of success they might have had.
Yeah, I mean, I think that's not where we're positioning CloudVision right now, right? We're really trying to do it really well and focus on what we know we can do better than anyone else with what EOS provides that traditional multi-vendor tools don't leverage, and then provide the best experience there while also integrating into the multi-vendor kind of more limited but important workflow of driving this across the broader infrastructure. So
hey, sorry, this is John. One question, you get these configlets that are created as part of the processes you've been running here. What's the level of smarts, or how does it react when there's a change to the running configuration prior to executing that configlet, which may conflict with what you've done?
Yeah, no, that's a great question. I think one of the biggest challenges for organizations in network automation is the organizational change, right? I'm not going to go to the CLI and make changes. And so, but we know that this happens, right? And we know that especially you're at 2 in the morning, you're trying to fix it, you just went and changed it. So actually in the approval process, when you approve a change control, if any of the devices you're going to change, their config changes, it's unapproved. Like you have to go look at it again and say, am I sure I want to do this? Oh, look, on this device, I'm actually going to go and remove this config that's there. Let me figure out what's going on. So that's the level, that's how we try to prevent you from hurting yourself. But it's a real challenge. I mean, I think part of the challenge is that the CLI as a model for configuration is really, right? Like it's part of my language, right? So like if we had a model data that we all use and that users would be able to use from a visual point of view and we're ready for, we could do that. I think OpenConfig gives us a nice path there. But that's the level of protection we provide, is really trying to make sure you don't go do something over something that someone then went and changed.
So do you offer protection or awareness? Because at one point it was simply an awareness, like, hey, now you haven't reconciled this, but hey, if you click go, you're going to stomp all over the code. And then what we'd talked about was, can you put like a safety feature on that says, no, you can't push that until it has been reconciled?
Yeah, I mean, I think what's hard is that it's hard to know whether you want it or not. Right, we don't know and when it came. Right, was it before or after you created your change control? And so we really leave it to you to decide: do I want this or not? I think the people who are the real way to solve this, right? And like I said, is the harder part. Is the organizational change of, look, I'm really focused on network automation. Everyone's going to do everything through the tool, and that often in many organizations comes from above, saying, look, we're going to make this change, and it's very hard if you don't make that change.
Yeah, no, but I'm not asking CVP to make the decision for me. I'm just asking for a feature that allows the customer to put a safety lock on it. It says, look, as a policy of our organization, we are not going to allow an operator to click the apply button unless it's been reconciled, versus just creating the awareness. Like, I agree that it's on the customer to make the decision, but in some cases we want to make sure that the user, in that case, might be like an operations person applying, a bunch of changes at 2 in the morning, and perhaps somebody forgot to reconcile something before, and they're just like, I'll just, select all apply.
I think it's an interesting feature. I can't help but go to the implementation details and think about the challenges there, but it's an interesting feature. Yeah.
All right.
I think there's two things that go with that, right? The first is Funnily enough, I wasn't even thinking about somebody going in on the CLI and making a change you weren't aware of. I was thinking if you approved the change and scheduled it to execute later, and then I come along or another engineer comes along and does an overlapping change, would it even be able to look ahead and go, well, by the time you're trying to schedule your second approved change, the config will have changed and therefore it will no longer be valid, right?
Yeah, you don't have that issue here because if you're building changes on top of what's been approved, right? So
okay.
So you don't have that aspect.
Okay, and then from the CLI perspective, this brings up the issue of what I hate to say what your source of truth is, but like where your configuration is stored and whether or not there's an ability to say, if I see a change that's been made by CLI, which I'll be notified about pretty quickly with the streaming telemetry, I'm pretty sure, to be able to say and push it back. Basically say, no, my source of truth is what's in CloudVision, and that config is pushed out. And if I see a change that is a discrepancy, I want to push out the approved config again and not.
Yeah, you can certainly do that. We don't have a knob for that, but you can certainly do that and say, nope, I'm going to push it back.
Right, so let's just quickly validate. We'll just finish this off. We'll show the broader topology view here. So going into the topology, we can get that network-wide view. So here's our data center connecting through to our campus. We just zoom into the campus. The lines are a bit hard to make out, but essentially we've got our new AP connected into this leaf switch here. And then because we store this state over time, we can then overlay that. So in the case of VLANs, we can visualize where the VLANs are configured within the network. Between the leaf spine, this is an L2 network, so we've got some VLANs trunked across the MLAG port channels there. And then down to our leaf switch our AP is configured on VLAN 14. So let's quickly move on to the last engineer type here, which is our field tech. And now, so we'll get an idea of how they're going to use CloudVision, not necessarily ways that you have to log into CloudVision and move through that change control process, etc. So our field tech, they're going to log into CloudVision still, but this time when they log in, they're going to get essentially a slightly different dashboard and a read-only view, so they can't go in and edit this. And this is just a simple campus dashboard that's got some PoE stats, some .1x stats, utilized interfaces, that type of thing. Now, this field tech is out on that new floor that's been deployed. He's looking up at the ceiling there. There's that AP, and he can see the wall jack, right? It's not registering with the cloud service. It seems to be getting power. So let's use Slack as a way to interface with CloudVision. In this case, I'm doing a port check command where I'm just entering the wall jack, right? So this is a wall jack that I can see, and it's returning the interface and the switch that that device is connected to. So we can then correlate that if we've got access to CloudVision. But in this case, we just want to shut the port down. So again, we're using Slack to shut down the port. And the wall jack's just a tag, another example of a tag. And you can see it update bottom left that immediately goes down once that command is executed. So we'll execute the port up equivalent, just a simple case of bouncing the port, right? Just a simple example of some kind of operations that I might have for a particular engineer within my network where they don't need to be concerned with logging into CloudVision, running through a change control for maybe some simple everyday tasks that are low risk. And there's probably many examples of this type of thing within organizations where this might be useful, and essentially using that CloudVision API as a means to connect in.
Does the CloudVision API now allow us to get the telemetry, the state telemetry data out through the API?
Yes, absolutely. Okay. So it's a gRPC-based connection that can be used to receive that telemetry data, and also then the same channel to push changes through.
So I would basically subscribe to, basically make a request to the API to say, I want to subscribe to whatever state data, and then CVP would then stream that to me.
Yeah, exactly. So you can subscribe to the paths of the state that you're interested in, depending on where that exists in the network.
Is there a way to just do like a get, or do I have to subscribe to the data?
Our approach here, if you're interested, I'm excited about this, is like, what I want to be able to do is write a script that can run against a switch or run against CloudVision, right? So what we expose is actually GNMI or RESTConf.
Right.
And It's not enabled by default today, but we can actually stream the full kind of OpenConfig Yang tree into CloudVision, and then expose it over gRPC. So like you could take a script that you're running against a single switch, run it against CloudVision, and get access to all switches.
Yeah. So if I wanted to
that's
get
our
like the
approach.
cable map, like for a set of devices, and I want to do that exact sequences, like, well, here's a bunch of REST conf paths, give me that data,
That's
so I can
And there are
just pull
some
that.
customers who are interested in this from a security perspective. Like, don't give access to all these devices, give access to CloudVision at this layer.
Yeah.
Okay, so hopefully that was helpful in giving you an idea of the types of multi-domain operations with CloudVision.